hopefully, I think I hear feedback. My mic is turned on. So again, my name is Tom Herbert. I work for the SDN group out of the Office of Technology in Red Hat. And today I'm going to talk about, try to form a comparison, if you will, between FIDO, FDIO, VPP, and OVS DPDK. So we work in both areas. I worked in both areas. And these two switches have some similarities, but they're remarkably different in a lot of different ways. And I'm try to see if I can get a realistic perspective on both approaches. So ask me any questions at any time, and I'll be happy to, hopefully we can get some interaction going here. And here we go. So first, I'm going to just do a little bit of introduction to VPP. Now, we're sticking pretty close to time here, and I could probably spend more time on this presentation. So if I skip some things that are more boilerplate that you can find out by Googling, don't yell at me, just go Google. And I'm going to try to emphasize the types of things that I think are more relevant to the kind of points I'm going to make. But if I gloss over some stuff that you think was important, just please tell me, and we'll do the best. So first, I'm going to introduce a little bit about FIDO and VPP, and we have experts in here who were from the start of the project from VPP who've promised to throw tomatoes at me if I lie, so like Keith back there, so we'll see. Anyway, so after that, we'll look at a little bit about the architecture of VPP, just to give you an idea of how dramatically different it is from the approach and from the history and every other respect from OVS DPDK. And then we'll review OVS DPDK, and I just want to go through some boilerplate issues that have pointed out some performance issues that show up in certain test cases with OVS DPDK that I think everybody's pretty much familiar with now, and how we don't know, but VPP has some likelihood of improving them. But I'm going to go on and talk about how perhaps with some perspective and some help with FIDO, the potential and the upside is enormous, but we don't have a huge amount of data on deploying FIDO in OpenStack cases and complex scenarios, so we don't really know how well that's going to scale either. It might have scalability issues for us, but we have known scalability issues with OVS DPDK, and no doubt we'll run into different issues with FIDO. So again, the FIDO project is, it was launched this January, I think it was, by a huge data dump from Cisco, and is completely open source right from the start. And it has quite a few people contributing, a lot of Intel people, a lot of Cisco people, Brocade, various other switch people, customer people, people from AT&T, Verizon. There's a pretty good wide variety of people involved in FIDO. So it's a pure open source project with a very broad-based governance. Everything's public. You can go to the site and so on. It's been used internally in Cisco for quite a few years. The code's very, very, very mature. I don't know exactly when it was ported to DPDK, but it goes back to some of the earlier sort of shady releases of DPDK back in 1.7 or maybe even before 1.7.1. So it's actually a multi-project project. It consists of sub-projects, the main which is the core forwarding engine, VPP, and the vRouter engine. But there's also CSET, which is, whoops, I knew I would do that. There's also CSET, which is a automated testing framework, which has some interest perhaps for the DPDK community and others. At NSH SFC project and various other projects. Honeycomb is the kind of agent and is kind of necessary for deployments in OpenStack and remote configuration of of VPP. And we'll talk about that a little bit more. Whoops. So FIDO is different from it's actually a V router, so it includes a complete stack of IPv4, IPv6, and various networking protocols. It basically has most of the functionality you're likely to find in a big iron router from Cisco or any of the other vendors. And that's its legacy, is to actually implement the capability of the big iron product in virtually. So it's kind of a different history. So how does it work? It's actually a digraph, graph architecture, and it works off packet vectors. So packet vectors input from DPDK and nodes on the graph pipeline process the packets, and each is a series of plugins. Each plugin registers a kind of a dependency. Another plugin looks for a particular packet field. And an example of a plugin is VXLAN NSH VTEP is one of the plugins, and there are others. So packet vector is read at one time in a burst, and as we know, DPDK is optimized for burst traffic, so FIDO VPP fits well into that. And then the graphs are receive the first graph, of course, the input will receive the packet vector, and then it can pass it on to other nodes. And it's a pipeline architecture, so it makes use of the kinds of things we're used to seeing in sort of a hardware-like look of the world with multi-processing architecture and so on. So an open vSwitch architecture, of course, has a totally different history, as you know. Open vSwitch was designed as the implementation of a virtual switch as defined by OpenFlow. So it's a pure or OpenFlow implementation, and that is its legacy. So when people started to talk about SDN and software-defined networks, there was really only one software, there are others, but one pure implementation of OpenFlow, and that was Open vSwitch. So when we look at some of the limitations we see with Open vSwitch when we accelerate it with DPDK, we just have to remember that there's an architectural kind of outlook which determines, it's like the biology, if you will, of Open vSwitch is different from the biology of VPP. So we have to look at them differently, and we can maybe deploy them the same as an OpenStack environment, but they're going to behave perhaps quite a bit differently. So for example, Open vSwitch, as we know, has if we look at guest interfaces or PMD interfaces, this is what it's likely to look at in a DPDK context. And so some issues we've seen, of course, that people feel with performance is because the way DPDK accelerates Open vSwitch performance is by doing the matches in an exact match cache, and there's different layers of caching. And if you can keep your stuff without having having miss in the exact match cache, the performance is absolutely blindingly fast. But the trouble is that it's small, and in some deployments we can have millions of flows, and so flow matching drops out of the exact match cache, and it gives you some drop-offs in performance which can be unpredictable and yield to frustrations on the part of people that expect that somehow the performance is going to be scaled linearly across a wide use of deployments. So if we can stay in the exact match cache, we see almost 1 order of magnitude improvement, or half an order of magnitude of performance, but it quickly drops off if we drop out of the exact match cache. And of course, without going into the details of the way OpenFlow works is if you don't have a cache flow in in the pipeline and you have to go to the controller, it gets extremely slow, no matter what's on your data plane. So the idea here is that DPDK can accelerate Open vSwitch fairly dramatically on certain use cases, but it may not apply broadly to a wide range of certain kinds of deployments, particularly in OpenStack where you have tons and tons and tons of flows, tons of MAC addresses, and so on. So, you know, performance optimizations can be done with DPDK, and they have been done. And of course, at this conference, we hear some of these slides I have that talk about the performance are a little bit old now. A lot of these issues have been addressed. And so it's a slightly different picture, but the theory is pretty much the same. So there's a challenge if we're going to compare performance and uses between something like VPP and something like OVS. And there's some perception out there that people get a little frustrated with OVS and they say, well, VPP is going to solve everything because it's faster, and we have these EONC tests that show, oh, gee, it's so much better. But maybe not in certain kinds of real-world cases. We need experience with VPP deployed like in an OpenStack context. So in OpenStack, of course, we have a FDS project, which right now is deploying, and I think some of it pretty much, maybe with some patches and hacks and so on, is in the Colorado release as a deployment of VPP, and we also have OVS DPDK project in OPNFV, which deploys DPDK accelerated OVS. So you have the opportunity to really maybe compare apples and with oranges for NFV use cases, and perhaps we will see. Right now, we don't have numbers coming back from those because everything is a work in progress, and you know, Yardstick is one of the performance measuring, and vSperf is not in all cases doing measurements quite yet on DPDK accelerated OVS and so on, and not quite on FDS, but it probably by this fall we're going to get some real world data out of this. So VPP will probably, guesses might be that it'll probably scale very, very well if it's a TOR type deployment, or it's something that looks like a V router, that looks like a traditional use of a router or switch, but who knows how well it's going to work when we have it sitting in a compute node, and we have varying traffic, and we have NFVs, and we have, you know, load balancing going on in VFs, and the VFs coming and going as they get migrated from place to place. It'll be very, very interesting. So again, there's some slide. I have some slides that I've used in several other presentations that compare how raw DPDK performance and scales that according to the way it's deployed in Open vSwitch with DPDK. So the DPDK can improve OVS performance significantly, and of course it involves consuming multiple cores. We know everybody here probably is quite familiar with this kind of thing. And DPDK also has a pretty good history of working very, very well with small packet sizes, which in telco use case is a must because of you know, legacy GPRS and so on. So there are similarities between both projects. I mean, I'm here talking about it. We're all here. So both vSwitches use DPDK, right? So that's a big similarity. They both can be remotely deployable and remotely controlled. They both use some version of vhost user for VM to host VM to host transmission. Although VPP is a little bit behind, and it's got some patches. It's not up to date with 16.07, and hopefully by the next release with 16.11, we'll have synced up with DPDK upstream. Container support is a big topic here in DPDK. We use excellent paper earlier this morning on accelerating container support. So this is an active, and we have the expert in the back here, but this is an active discussion going on in deploying VPP for accelerating containers while taking advantage of some of the things that we're doing in DPDK. Including user space netlink is one of the possibilities. We have some of the formatting here is a little bit off. We use Google Docs a lot at Red Hat, and when I rendered these slides and sort of translated them into PDFs, I had two versions. One, the Red Hat logo disappeared. It just turned into this sort of like poorly rendered kind of funny thing, and on the other one, the formatting kind of went off. So I went into Office Libre and fixed up the formatting a little bit, and then re-rendered them. But it reads kind of funny, so I have to apologize for that. So the architecture again, and I kind of touched on this early. So Open vSwitch is based on OpenFlow, and the OpenFlow, of course, has a concept of matches and actions and tables internally. It has a fast path, which traditionally was the Linux kernel module, and now a fast path through the NetDev interface accelerated with DPDK. The fast path has an exact match cache. If you could stay in the exact match cache, you'll get blindingly fast performance. And if you drop out of if you have a cache miss, you get a dramatic drop in performance. If you go to this low path, you get an even more dramatic drop in performance. And this I showed it in an earlier slide I can go back to if anybody wants me to. But on VPP is very different. So it's a graph vector processing engine, which is graph theory based. It consumes a vector at once of input packets. It's optimized for kind of a parallel approach of implementation, and it looks like it could scale a lot better. There's also the limits of the size of the amount of routes you can cache. The amount of MAC addresses you can cache are really limited by memory sizes, and it does a lot of those things kind of well. I mean, it is a vRouter, and it's just a different approach. It uses techniques like branch prediction to optimize the code, and so it's not just that it absorbs a vector of packets, it's that it intelligently generates code which optimizes other features in modern architectures like Intel and others to go as fast as it can. And these are probably one of the prime benefits of VPP. So in this sense, the promise is there for better performance, for better deployments. Open vSwitch was never really originally written except for as an implementation of a pure SDN type switch. And after the fact, we've gone in and had tremendous luck trying to accelerate Open vSwitch, but it's a different kind of code base. It requires different techniques. And we don't know for sure yet how this will come out. On the control plane, there's dramatic differences. So if you look from the top down, from the point of view of OpenStack, for example, Open vSwitch again is an SDN controller. It's managed by OpenFlow and OVSDB, whereas VPP is netconf yang. It's originally or via CLI. It's a very different, quite a bit different approach. So generally, the way we're looking at things, we being Red Hat, and we're very ODL focused. We have a large group of people that work on ODL. I do data planes because I have a bad personality, so they don't let me work on ODL. But so we think that the advantage of ODL, that's the open daylight, controller as a middleware component in the control stack is it can make some of the differences between the two switches sort of invisible for OpenStack deployments because it's just another mapping. It already does OpenFlow very well, which is harder to do. To map high-level policy to netconf yang and then do another map to netconf is relatively straightforward from that standpoint. I think I've already covered why the performance is those performance scales are useful by way of comparison, but don't quote the numbers. So the outlook, again, VPP shows a lot of promise. It is well suited. It's a good citizen to work with DPDK, maybe a better citizen in some ways of OVS because DPDK is vector, it's burst oriented, and VPP consumes packets of vectors. That kind of looks good. And so, but we need to look toward real-world deployments. We need to look to OPNFV. I'm sure many of you are familiar with OPNFV as kind of a telco-focused OpenStack middle open source project that deploys OpenStack for that kind of customer base. And I, for one, and others think that it will show a lot of promise in terms of giving us a good idea of how well and what needs to be done, what needs to be improved upstream in VPP, what needs to be improved upstream in DPDK and OVS, so these both can be quite useful. So there's some issues with VPP in that it's easier, it's very complex in OVS to make changes like NSH SFC, which some of us have been working on, have been very slow to be merged, and there's frustrated people. And that's largely because of the OVS architecture and the fact that changes have to go in the kernel module, and even though we're working in DPDK, we still have to implement the changes in kernel modules so we have the same functionality in both data planes. And there's various other reasons that can slow down deployments in OVS, and VPP isn't burdened with these considerations, so things perhaps maybe can move faster. So I think I pretty much covered this, and I'd like to leave some time for questions and discussions. So I know I glossed over a lot of details here, but and hopefully I hit the main points. If you have any questions, please shoot, or don't shoot me, but shoot the questions, or you can shoot me if you think I've been that bad. But and afterwards, I'd be happy to talk to anybody and talk about what we're doing and what we're doing upstream with at Red Hat with these projects and what our focus is on data planes and all kinds of things like that. But go ahead, ask. Well, either maybe everybody's anticipating lunch, or maybe I don't see too many people sleeping. Usually if you get above like 15–20% sleeping, you know you got a problem. But unless toward the end of the day, you know, if it's 4 o'clock, then you expect 60% of the people to be sleeping. But in the morning, it should be 5 or 10, and you're okay. It's a good way to judge as a speaker, to judge how your talk is doing. But anyway, if you have any questions formally and informally, go ahead.
Hi. Okay, I have one question. So regarding VPP community, because you're in, when VPP will jump on vhost user regular, because VPP is using their own version of vhost user. So can you elaborate on why you're using it and when they will jump on the on the official DPDK vhost user version?
Okay, I believe that in the 16.11 release, And VPP uses the Ubuntu type of, release planning. I worked with Ubuntu for 2 years before I realized what that 14 number meant, or 13. But when I figured it out, I thought it was a good idea. But anyway, VPP is using that release, so 16.11 should be hopefully integrated and use the latest vhost user and use DPDK 1609 for DPDK should be integrated or with. So right now, it's kind of like 1604 with a bunch of patches, and one of those, and a sort of local version of vhost user. And you ask why? It's just the legacy is that and maybe Keith or someone can tell you the long history because I haven't been involved, but it just has to do with the timing and when the VPP project came about and what was done internally in Cisco before it was released open source to the world, let loose, and the baby was born in January. A big baby too, because it had already grown quite a bit. So that's really the history. There's no technical reason. There are technical limitations, but hopefully we can make this work by the end of this year.